All right, guys. We're on to section 10.2 of the data and stats chapter. We're looking at populations, samples, and hypotheses. So it's just a lot of vocab. So let's take a look. A population is the collection of all data, such as responses, measurements, or counts that you want information about. A sample is a subset of a population. So a population is basically, obviously there's no point in just regurgitating this. Like, if you don't, like you didn't know it before, so just reading it doesn't mean you definitely know it. So putting it in my own words, I would say a population is the big group that you want to know about, and a sample is a part of that group. And I'll give you, let's just break it down very quickly first. So population, the big group, sample, a part of the big group. So the population could be broken down in many ways. We might say, the population is all the students at Independence. And we might say, a sample of the population is the freshmen. Or we could say, the population is the freshmen, but the sample is the freshmen that are taking Math 1. Or we could say the population is not all Americans. We could say the population is Americans, and then a sample is just some group of Americans. We could say a population is all Americans over 18, and then a sample is all Americans over 18, maybe with a job or something like that. So again, anything, a population is the bigger group, and then the sample is a part of that bigger group. A subset means under, a set under. So next, the vocab is a numerical description of a population characteristic is called a parameter. A numerical description of a sample characteristic is called a statistic. So parameter and a statistic are the same thing that applies to different groups. So a parameter is a number description that applies to the whole population, and a statistic is a number descriptor that only applies to a sample. So numerical descriptor that applies to the whole population. Numerical descriptor that applies to the sample only. So a parameter might be something like, in everyone in math, out of everyone in math 3, a quarter of the students have a favorite color of white. And that could be the parameter. That means 1 out of every 4 students in math 3 likes white. If I wanted to give a statistic, so that would be the parameter, because that applies to everyone in math 3. If I wanted to give a statistic, I could say, 100% of the people in group 1 in math 3 have a favorite color of white. So those are two different numbers, right? Like, everyone in group 1 likes white, versus a quarter out of the whole math 3 likes white. Like, 1 applies to the whole group, and 1 applies to a small subset. And then lastly, a hypothesis. So a hypothesis in a science context is an educated guess, right? In stats, a hypothesis is a claim about a characteristic of a population. So it's just, you are saying something about the whole group. And then in the textbook, there are a couple examples. For me, then, a previous example that I already gave is, a quarter of math 3 students, favorite color is white. Like, that's a hypothesis. Something I'm saying about everyone. Or 10% of Americans, don't like turkey on Thanksgiving. Okay, well, I'm saying something about the whole group. So that's a hypothesis. Hypothesis. A claim made about the population. So the reason why we make these distinctions between the sample and the population is because just because I take a small group doesn't mean that they speak for everybody, right? So if, let's just use a really obvious example. Let's say if I have one group of students that knows the material really well for a chapter, and this group for some reason is the only one in the whole period that knows what they're doing in the chapter, then if I sampled everyone, if I sampled just them and said, hey, do you guys think I should make this chapter test worth double? And be like, yeah, they would say yes, for sure. I want it to count more because I understand it. And if they're the only people I ask, well then I would be like, okay, well the whole group wants it, so then I could say, oh, 100% of the sample I asked wants for the test to be counted as double. Are they representative of the population, the whole period, or both Math 3 courses? Probably not, right? Like if no one else wants it to count, nobody probably even wants to take the test if they don't understand it. Meanwhile, this group of that for some reason just really understands this chapter will definitely want to. So sample is just a part, and you survey them, but you have to make these distinctions because you are basically guessing when you take a survey that those people are representative of the whole population. So let's go through a couple examples. Identify the population in sample, describe the sample. In a city, a survey of, why am I here? It could be. A survey of 3,257 adults ages 18 and over found that 2,605 of them own a tablet. So what's the really big group overall? In a city, a survey of 3,257 adults ages 18 and over. Well, do you think there's only 3,000 adults ages 18 and over in that city? I mean, it would be a pretty small city, right? So the population is the biggest group is adults ages 18 and over, or the population. Sorry, the population. Adults ages 18 and over in the city. And the sample. The sample is the smaller group, which is we've only surveyed 3,257 adults ages 18 and over. Describe the sample. Well, if I've asked 3,257 people and only 2,605, so 2,605 of the 3,257 own a tablet, what does that say about the rest? If 2,605 of them have a tablet, that means the rest of them do not. The rest, and we should definitely attach a number to it, which you could just use subtraction. 652, it looks like. The rest, 652, do not own a tablet. Let's double check our work. 3257 minus 2605. Cool, 652. Moving on. To find out the consumer's response towards a new flavor of sports drink, a company surveys 1,000 athletes who drink sports drinks and finds that 726 of them like the new flavor. So the population, well, they're surveying only athletes, so that must mean that they're coming from a group of athletes. So the population is just all athletes, I suppose. All athletes who drink sports drinks. The sample is 1,000 of them. 726 like it, and then the rest, however many that is, 274 do not. Okay. Determine whether the numerical value is a parameter or a statistic. So again, we're really just, they're going to give us a number no matter what, because parameters and statistics are both numbers, but one applies to a population and one applies to a sample only. So you basically are, what it's asking you to decide is, oh, is this talking about the whole group or just a small group? 82% of the residents in one neighborhood in a town voted to approve building a bike lane through town. Okay, so let's read this carefully. 82%, so it's a pretty big majority of them, of the residents in one neighborhood in a town voted to approve building a bike lane through town. So we've only asked people in one neighborhood to make a decision for the whole town. Is one neighborhood of a town represent everyone in the town? No, because there's like a bazillion neighborhoods, right? Well, we don't know how many there are, but typically there are more than one. So you can say this is statistic. One neighborhood is a sample. Population would be all neighborhoods / everyone. So again, no matter what, they're going to give you a number. A parameter goes for the population. A statistic goes for the sample. I guess it really helps that parameter starts with a P and statistic starts with an S. So parameter for population, statistic for sample. In a science class, 25% of the students wear glasses. Did we only ask one chunk of students? Or is this referring to, have we surveyed all the students? In a science class, 25% of the students wear glasses. Well, we've surveyed everyone. So this is the population of the whole population in this context is the science class. We've surveyed everyone. So this is a parameter. The 25% refers to the whole class and not just a sampling of the class. Or you could say not just a sample or sampling of the class. In a recent year, the median household income in the United States, median household income. So that's median. That's when you line up all the numbers from least to greatest and you find what's in the middle. Well, in the description, you line up all the numbers. If you line up all the numbers, then median is a parameter. It's talking about everyone. A survey of some visitors. Well, to a museum found that 84% thought the new planetarium was very exciting. Look, there's the keywords. Some visitors. We're talking about everybody. We're only talking about somebody. Some bodies. Well, this is not everybody, so it's a statistic. So, again, this is just vocab. Your ability to differentiate between a whole group, a population, and a sample, which is just a smaller part, a subset of the population. But if you want more examples, then just ask me in class and I'll come up with more examples.